Hi everybody, we're going to get started soon. Hang out for just a bit. I'm just tidying up my desk so I have space to write. I'll be right back. Alright. I should be able to hit this button. Boop. And it should show you my browser. This is the Canvas webpage. What we're going to do today, to start things off, is we are first going to learn how to access all the lab material. Oops, I don't need the pen yet. What am I doing? And then once we've learned how to access all the files, then we'll do some practice problems and talk about how you submit your answers. And then finally, once we've covered all that, we're going to go over a Q&A where you just... excuse me, hold on. I need to drink more water. We're going to go over a little Q&A where you just ask me questions. I'll do sample exercises for an hour or so, and then we'll call it a day. This probably won't take the whole 2 hours. I did this earlier for a different class. We were finished in 1 hour. They didn't have that many questions, so depending on the number of questions you have, the longer it'll go. But I'm happy to stick around for the time that you need it. So first of all, let's start by being in Canvas. You will need to have access to Google to do this, so either anonymously or logged into your student email. Either one works. But what this is going to do is, first of all, you're going to go to the Modules tab. And that's going to show you this screen like you've seen many times before. If you don't see all the slides, that's because you haven't done the orientation lecture and orientation quiz. You need to do that, and I know who has and hasn't done that. So if everything is blank, you need to do that before you can do any of this. You can see some other stuff in here that isn't on your screen. That's because it's not published. There's other stuff that I might accidentally scroll down to. This is just old stuff. That'll never show up. So if you see things that aren't here, don't be surprised. Because my screen is a little bit different than yours. What you're going to want to do is you're going to scroll down past all the lecture slides to this right here that says Laboratory Worksheets. And there's going to be 3 things. We're going to go over all of them today. The first one is how to upload your completed worksheet. That's going to come a little bit later, but importantly, this document exists. It has a bunch of pictures that show you how to copy the worksheet that we're going to do. We're going to do all of this live. And then finally, how to submit your form at the end. So I'm going to reference this a little bit later, but just know that that's there. Know that you can grab it when you need it. The next thing that we're going to talk about is how to get to the worksheet. So if you click on this link, it will open this screen right here. This is a PDF file of the assignment that I'm asking you to do. The PDF file has a lot of discussion of stuff that we've covered in class. This is just part of the lab. It is another piece of information that you can use to supplement what you've learned. So it talks about scientific notation. It talks about significant figures. It talks about how to do rounding and dimensional analysis and stuff like that. And it's got a bunch of stuff in here that you can read that is basically what we lectured on yesterday. Okay? When you scroll down far enough, down to page 7 of this document, you're going to see what it says Worksheet Exercises. On these problems, what you're going to do is you're going to solve these problems that are asked. So like right here, convert 5.2 quarts to liters, convert 1.36 feet to meter. You're going to solve all of these problems on paper on your own, and you're going to report the answers somewhere. Keep the answers handy, because what you're going to do later is once you've answered all 25 questions, and then there's a little blurb at the end that tells you how grading will be done. Once you've done all 25 answers, you're then going to go back to the modules. You're going to click on this right here where it says Google Sheet number 1. And that will lead you to this screen right here. The first thing that you want to do when you get to the Google Sheet is you want to click on the banner up here so that you open it in a new window. And that's going to look like this. Okay? This is the worksheet that you're going to input your answers into. Now, I can type whatever I want to into this box right here, but you guys can't on this sheet that has been linked to you. The reason for this is because if you enter it, everyone can see it, and then one person would do the assignment, and then everybody would just turn that in, and that's obviously no good. So what I'm going to do is show you how you make a copy of this that you can input data to on your own, okay? And here's how that works. The first thing you're going to do is you're going to scroll up here to File, and you're going to click Make a Copy. Now, in order to do this, you do have to be logged into Google on some account. It can be any account you want. It could be your student email. It can be a personal account. It could be whatever. As long as you have a login and you can access it, you have a Google Drive. When you click on Make a Copy, this screen will appear. Name the document. You can name it whatever you want. I would just leave it the default. You do not need to check these options. It will save it to your drive, and you hit OK. And a new screen will appear with your copy once it loads. And for some reason, it takes a while on my connection. I think my internet is not being great. But once it has made a copy, any day now, Google, you can do it. Do. I'm sure it'll go much faster for you guys. I don't know why my internet is just crapping out at times. Now you have a copy that you can do whatever you want to. So you should be able to type in your name. You should be able to type in answers in the fields shown below, and so on. Here is how doing these worksheets works. First of all, anything that is light blue and has a bold border is something that I am expecting that you will type a number or answer into. Okay? So in order to have a complete worksheet, anything that's in blue has to have something in it. Okay? Anything that's in white is not going to be graded. So if you type stuff over here, you can, but I'm going to ignore it. And certainly if you scroll way over here into the distance and write some sort of message or whatever, I'm never going to see it because I'm only going to be looking at this screen. Okay? So don't type anything off in the wilderness where I won't find it. It's got to be in these blue boxes. To fill in your problems, you're going to take whatever your answer was for number 1, and you're going to type in its number. Let's suppose it's that. Then you're going to tell me what the units of your answer were. And then you're going to tell me the number of significant figures in the number that you reported. Okay? I don't know what the answer is to number 1 because I haven't actually done the problem yet. I've only just written the problems. I have an answer key that I'm going to prepare later on. And you're going to do this for all 25 problems. Some problems will direct you to put units in a certain way. So, for example, you guys don't necessarily have the degrees. That didn't even do anything. You might not know how to do the degree symbol on your keyboard. Typing in this for your unit is fine. Some problems will actually have no units in them, and it will say type in no units. Make sure to do that. Don't leave it blank. Make sure you indicate somehow that you know that there are no units, okay? Excuse me. On the left of the screen is a gray column. It says, do not write in this column. This is for my use only. This is for grading. When I punch numbers in here, what it does is it gives you points, and those points appear up here on your score. Okay, so this is basically my grading column. I can do whatever I want to. This is just going to be filled with 1s, 0.5s, and 0s based on how you do, according to the grading key. Okay, so don't write anything in there. Don't delete anything that's there. You'll see that there are formulas written in certain spots. If you modify anything in this, then I won't be able to use it to grade, and then that will make me cranky, and that's not a good idea. When you have finished the assignment and you've put all of your answers in here, what you need to do is you need to save a copy of it. The way that that works is you go to File, and you click Download, and very important, you have to pick this option right here, Microsoft Excel.xlsx. This is the file type that I can open on my computer. Don't do Open Document because I don't have OpenOffice. Don't do PDF because I can't edit that. And certainly don't do any of these other ones because they will just give you raw text. That's no good. You want to do Microsoft Excel. So you click that. It's going to prompt you for a place to save it. You could save it wherever you want to. But what you're going to want to do is when you save your file, you're going to want to give it a certain file name. The file name is shown in the How to Complete and Upload Worksheets document at the very end, which I'm putting on the screen right now. So if I scroll all the way down to here, oops, where is it? There it is. In page 3 of the document, you're going to see, here's how to save your file name. Make sure you save it in this convention. The convention is last name, a space, your first name, a dash, Chem 121 OLS, and then whatever lab number it is, lab 1 for this one. You can either do that when it prompts you to give it a name to save to your computer, or you can rename it later using the rename option when you right-click on the file. But when you upload the file, it has to be in this format, or I might not know whose it is, and then I won't give it to you. I won't assign the correct credit. I want to make sure that I have your file on the file name and in the worksheet. Okay, have it in 2 places in case one of them goes wrong for some reason. Once you've saved the file, the next thing that you got to do is you don't want to open it on your computer. Don't do anything to it. You'll want to go back to Canvas, and you're going to scroll up to this tab that says Assignments. And when you click on that, you'll see a list of assignments that are currently going. This includes all your quizzes and things like that. And again, when it loads, here's all the assignments that are currently going. So you have the orientation quiz. I unlocked quiz number 1. You'll see it's due. Here's worksheet number 1. You click on this link right here, and it will say, please upload your file. I just realized I'm not in the student view, so hold on. Let me turn into a student real quick. Okay, now I'm a student because the border's pink. So this is what you'll see, Lab Worksheet, and it will say, please upload your file, and you click up here, Submit Assignment. Now you can choose the file that you downloaded, so I'm going to do that really quickly if I can find it. There we go. I have the 161 one, that's fine. And then you hit Submit. And once it uploads it, and it's going to take a second because, oh, and I guess there's confetti because you did it. Hooray. I'd never seen that before. That's kind of neat. Now you're all set. Once you see this that says it's submitted, you're good to go. If you submit it and then for some reason you look at it and you're like, oh crap, I made a mistake, I need to resubmit it, you can always resubmit the assignment. Make sure that the file name is the same as the previous one you've submitted, and just repeat the process. Okay, let me reset the student so I can do this again if I have to. And let's not be a student anymore. All right, there we go. So that's the general process on how you go through the lab worksheets, how you download the file once you've filled it in, and how you upload it to me. I will receive those files that you have sent, I will then grade them, and then I will return them to you so that you have a score, and the score will be put on Canvas. Okay? I'm not actually sure how I'm going to email the files back. I will figure that out once I get in contact with eLearning. There's probably a batch way to do that where I can just link a file to your account. Otherwise, I will just send you emails with the files attached. Whatever it works, I will figure that out once it's due. When is the assignment due? Well, I haven't set a due date, but I am going to do that right now. So the assignment will be due at the following time. And you'll see the calendar in a second. So it's due Thursday on the 30th. So you have a week from tomorrow to turn it in. You get a whole week to do this assignment. The deadline time is 11:59. That's just the time that it needs to be sent to me. You can turn it in at any time during that day. You can turn it in any time before that. If you're already done with it, you can turn it in now. I just need to have it by April 30th. If you're over by like an hour, that's fine. Like, that's not a hard deadline, and it won't close because I haven't told it to close. It will flag your assignment as late, as long as it's not too late. And what I mean, like, more than like 8 hours or something like that. Like, if I wake up and it's not there in the morning, then that's obviously a problem. But if you're working late into the night and you turn in at 3 a.m. and you're like, oh, I hope the instructor isn't upgrading these, don't worry, I won't be. And it'll be fine. The late penalty generally is going to be 50% if it's late. So make sure that you don't lose half your points for turning it in like 3 days later. And also remember that there is an NQA coupon available in the syllabus. You can extend the due date for any one assignment for as long as you need. So if you need that, make sure that you remember that that's a thing. Okay, so I'm going to hit save. And now an email will be sent to everybody that says, hey, an assignment was changed. There is now a due date. Okay? All right, that's it. That's it for the lab. That's all you got to do. I mean, I say that in terms of it being straightforward, but once we have done this 2 or 3 times, the practice will become second nature. For the purposes of the rest of the period, what we're going to do is answer questions. I can see that there are already questions in there. I can't do the specific questions that you are asking, but I can make up similar ones if you'd like. So if there are particular questions that you want to go over, I'm happy to do that. I can do other examples from the textbook. I just have to go find my textbook. There it is, right there. I put it on the table. That was smart of me. Usually I leave it in the living room. I didn't get any questions emailed to me that needed to be gone over here, so this period is basically just a, hey, let's work on some problems, which I'll put this on the screen. And we can do stuff. So let me know what you want to do. If you have a specific question or a specific problem that you want to go over, let me know. Let me look at what number 21 is. So 21 is a problem that asks you to find the volume of a block. We can do an example of 21. We can look at 23 through 25. We haven't actually done 25. We're going to talk about density tomorrow. But I can briefly give you an example. So let's look at 25. Or not 25, I'm sorry, 21. So 21, I'm not on the right screen. Hold on. There we go. Okay. 21, I'm not writing on the right layer. There we go. 21 asks you to find the dimensions of a block. And so I'm going to draw a block on the screen. Now the volume of any block is equal to whatever its length is times whatever its width is times whatever its height is. And what I've done for you rather rudely is I've given you lengths, widths, and heights that are in all different dimensions. And let me see what those dimensions are. So I gave you inches and centimeters and feet. So we're going to do something similar to that. Let's say that it is 32.9 inches wide and its height is 49.726 millimeters. I'm going to change the units up a little bit. In order to find the volume of something, all the units have to be the same. And I've also told you that I want its volume in milliliters. Okay? Now, how do you get milliliters out of this? Well, in the slides and also in the documentation is a hint that talks about the volume of water and how we can measure water in cubic centimeters, and that whatever its volume is in cubic centimeters is equal to whatever its volume is in milliliters. So milliliters and cubic centimeters are the same thing. This is a major hint on how I want you to solve this problem. In order to find the volume of this cube, I got to times all these things together. But if I were to times something in feet, times something in inches, times something in millimeters, I would not get cubic centimeters as my unit. I would end up getting whatever feet, inches, millimeters is, which is just some bizarre, bogus unit that nobody wants. So instead of doing that, what we want to do is make our answer have... why isn't it writing? There we go. Answer. Oh, weird. Why can't I... Oh, I know why. Hold on. It's not showing me the guide, but I was writing in the guide. Okay. Oh, I moved my screen a little bit. Hold on. Oh, I'm using the eraser. That's why my pen isn't working. So our answer needs to be in cubic centimeters. So what that means is that all these numbers, you've got to convert them into something that when you multiply all the units together, will give you cubic centimeters, because that's what we want our answer to be in. So that means that I have to take these numbers and turn them all to centimeters. Then I can multiply them all together. So for instance, if I was going to do that, let's start with this one here. And I want to convert this to centimeters. So I have feet, and I want to go to centimeters. Is there a conversion between feet and centimeters? Off the top of my head, I don't know one. But what I do know is that I can turn feet into inches, and then I can turn inches into centimeters. And the relationships that I have there are, in a foot, there are 12 inches. And in an inch, there are 2.540 centimeters. And those numbers and relationships are from your textbook. The feet to inches one you probably already know because you're familiar with it. So now that we have set up our links, just like we did yesterday, now we can go over and set up the problem to do the dimensional analysis. I'm starting with feet, so I don't want it. I'm going to turn it into inches. So feet goes down there to cancel it. Inches goes on the top. I don't want inches for my answer, though. I'm going to turn that into its linked unit, which is centimeters. So we'll do another one. Inches to centimeters, where these cancel out. Centimeters is what I want. It's the only unit that's left. It will be the unit of my answer. Now that I've done step 2, which is to fill in all the units, I can then do the numbers. Now I'll take these relationships and just put them up here. There are 12 inches in a foot, and there are 2.540 centimeters in 1 inch. So when I take all of these numbers and I multiply them with the calculator that I put away, for this I get 2 times 12 times 2.540. And I got, for my answer, I got 60.96 centimeters. And then, like always, we have to go figure out what Sig Figs are. So this has how many Sig Figs? That 0 is not a placeholder because the decimal rule. So we're going to count it. This has 2 sig figs. This 12 and this 1 are actually an exact definition. So they have infinite sig figs. This 1 is also exact, but this 2.540, as written, looks like it has 4 sig figs. It turns out that this is actually exact, but I would not fault you for not knowing that. In the end, it does not actually affect our answer because this is going to be the smallest one, so our answer is only going to have 2 sig figs, which means that I have to round it to 2 places, which would be this 6 and this O. The next digit is 9, that rounds up. So my 2-foot dimension will be 61 centimeters. So this first one up here, I have turned into centimeters. You would have to do that with the width as well, and also the height. And once you have all those numbers, then you can put them into the formula, because they will all have centimeters, which will give you centimeters cubed when you multiply them. And then 1 centimeter cubed is a milliliter, so you can just change the unit to milliliter, and that's your answer. Obviously, that takes a lot of work. That's why I'm making you do it, because I want you to really know how to do these types of problems. It's just unit dimensional analysis conversion chaos. And the point is, how do you figure out what you need to do from all this information? Okay? That's 21. Are there any questions on 21? Let me know in the chat. I'll go look up what the next problem is. I think somebody wanted to see 22 also. Was that right? I don't know if I had a speed problem in the slides yet. We're going to do similar problems tomorrow, hopefully. I could do one today, obviously. Let me erase what's on the board here. Did that get everything? It did, okay. So 22 asks you to take the speed of light and change its dimensions. I'm going to give you a different problem to do. To answer Abby's question, so you get 3 length, width, height answers, and then you need the volume. So remember, the volume is all 3 of them multiplied together. So you want to tell me the product of those 3 things. So like if you got 10, 2, and 5 for your L, W, and H, then you would times them all together. 10 times 2 times 5 is 100. And you'd report 100 as the answer in cubic centimeters, which you then turn to milliliters. Let's see here. So let's do 62.8 miles per hour to meters per second. So for this problem, this is similar to number 22. It's asking you to convert a rate or a speed into a different set of units. And so what you have to do is you have to convert your units so that these units match these units, just like we've been doing before. But now there are 2 units. So what do I do? So the first thing I want to do is show that this division sign right here is the same as me writing this number like this. Now you might have been wondering, like, if I always start with nothing on the bottom and just a number, why I've been drawing this line when I start doing my dimensional analysis. And the reason for that is because if you had a problem where it says turn a conversion to another conversion, You just have to start with a conversion, and you have to put the unit somewhere. So what the problem is asking you to do is you got to turn miles per hour into meters per second. We're going to break this into two separate problems. I want to do the miles part separately from the hours. So I'm going to go over here, and I'm going to turn my length unit, miles, into the target length unit, which is meters. So I need to figure out a way to do that so that I can, and you know what I'm actually going to do? I'm going to move this. That's not what I wanted to do. We're going to paste that over here, because I'm going to run out of space if I do. Okay. And I went off the screen, didn't I? Hold on. That's not what I meant to do. There we go. You'll be able to see like the little like Photoshop info at the bottom, which isn't super useful to you, but don't worry about that. Okay, so I want to turn miles into meters. Do I have a relationship that turns miles directly into meters? I don't, but I do have kilometers, and I can look up the relationship between miles and kilometers. And then I can turn kilometers into meters. So, let me go get those relationships. 1 mile is equal to, and I think it's 1.609 kilometers. And then down here, 1 kilometer is 1,000 meters, or 10 to the 3. And now that we have that part set up, we can go up here and do the problem. So just like before, miles, I don't want it. I'm going to turn it into kilometers by putting miles down here and canceling it. And we'll turn it into kilometers. Kilometers isn't the answer that I want. I want to turn that into meters, so I'm going to do another dimensional analysis. We'll do kilometers and then meters. And then just like before, once you've got all the units set up, you're going to do the numbers. 1 mile, 1.609 kilometers. My pen kind of got away from me there. Hold on. 1.609 kilometers per mile. And then 1 kilometer is 10 to the 3. And normally what we would do is we would say, okay, do our units match the target? Well, the meters does, so we'd hit enter and type it in the calculator. But you'll notice here that this meters is set, but I actually want this in seconds. And the units that are left over, if I hit enter, I would get meters per hour. But meters per hour isn't what I want. I want to turn hours into seconds. So what I have to do now is I have to do another one of these conversions to turn hours into seconds. And so we do the process again. So back at step 1, do I have a way to link hours to seconds? And I do if I have minutes involved. Because there are 60 minutes in an hour, and there are 60 seconds in a minute. And now you might be asking, well, how do I get rid of hours here? Well, if I multiply again and do another conversion, I could cancel out hours over here and turn it into minutes. Now, your gut instinct might be, oh, I'm just going to do what we've been doing before and just set it up like this. But you'll notice that this unit can't cancel something that's also on the bottom. Those would multiply together. So if you have a unit in your conversion that's on the bottom, where do you put it so that it cancels out? Well, if you can't put it on the bottom, you put it on the top, because this will now cancel out with this. Remember that since we're multiplying, you can multiply in any order, so this could effectively be right here, and I could just cancel it out in that spot. I'm going to turn hours into minutes, just like I would do any other dimensional analysis problem. Minutes isn't what I want on the bottom. I actually want seconds up here, so I'm going to do another one. I'll cancel out my minutes to leave seconds. This is where I want it to be. I want seconds to be on the bottom because that's where it is in my answer. So now that my units are set up, I can do the numbers. What's the relationship between an hour and a minute? Well, there are 60 minutes in an hour. And same over here, there are 60 seconds in a minute. And now I'm all set. I can then put this in my calculator. Now with your units, what's going to happen here is that only the units that aren't canceled out remain in your answer. That's this right here and this. So when I get an answer, I have to keep those units. Then what I have to do is I have to type all of this into my calculator. So you're going to type in 62.8 times 1.609 times 1,000 times 1 times 1. Then you're going to push divided by, and you're going to put a big parenthesis around the bottom. Parentheses, 1 hour times 1 mile times 1 kilometer times 60 minutes times 60 seconds. Close the parentheses, and it'll give you an answer. If you've got a calculator handy, punch all that in, and if you've done it correctly, you should get the same answer as me and my cat here, who just showed up. My go am working. Alright. And the answer that I got when I punched it all in the calculator was 28.068 and a bunch of ones meters per second. And then finally, after we've got our answer, we have to do Sig Figs. So make sure that your answer has the correct number of not Sig Figs, but the correct number. Let's check for Sig Figs. Any measured value that I give you is going to have a number of Sig Figs associated with it. This one has 3. This conversion here that I looked up had 4. And all of these, turns out, are exact because they are definitions, and exact definitions have infinite Sig Figs, so they don't affect your answer. The smallest of these was 3, so our answer should only have 3 Sig Figs, which means that I have to round to 3 places, which would be 28 point. This rounds up to 1. And there you have it. So if I was asked to convert 62.8 miles per hour into meters per second, that is how you would do it. First do the miles part, then do the time part. Do it one at a time, and then if your units match up with the target units at the end, you will be all set. For the speed of light one, you're going to be given meters per second, and you have to do miles per year. So you're going to have more steps. Meters to miles isn't any more involved than what we just did, but seconds to years is. So yours will just be a longer problem. And it should be a very large number, because light goes really fast and it can travel a lot of miles in a whole year. All right, if there aren't any more questions on 22, let me look at 23. '23 and 24 are pretty similar. I'm going to hit clear on the screen here. So make sure you've written down anything. Oh, it's gone. Sorry. Oh, it didn't select everything. That's weird. What if I do this? Did I write on the wrong layer? I made a new layer. Why did that happen? Delete layer. Deleted. That's gone. All right. Don't worry, it's on the recording if you didn't copy it all down. I assume everybody was done because nobody said anything. 420, I don't have a cursor. There we go. For 23, what it's giving you is a formula. So I'm going to make up a formula. We're going to say x, y, z equals AB. And let's suppose that you knew the following numbers. So you know that x is 38. You know that y is 492.5. You know that b is 20.4297. And that a is 0.0216. So there's just some random numbers in my formula. What you don't know is z. So if you're ever given an equation and you have a variable that you don't know, since you've taken a Math 86 before, you know that you have to solve for that variable. So I have to take this equation, and I have to make it so that z is by itself. I have to solve for z. So the way that I would do that is if z needs to be by itself, I need to divide this side by something to get rid of the other things. And that something is, well, it's what we've been doing all along with dimensional analysis. If I want to cancel these out, I got to divide by them so that they cancel. But with equations, anything you do to one side, you must do to the other side. Otherwise, it's not an equation anymore. So having done this, my equation now becomes z is on the left and it's by itself. And then I have all this mess over here, AB over XY. Now that I have all this, all I gotta do is plug in the numbers. So here's A. So A is just that number. B is this number right here. Divided by X, which was 38. And Y, which was 492.5. This decimal point didn't really show up much. Let me draw that bigger. And that all equals Z. And so now I just punch this into my calculator. And again, be careful with parentheses when you are dividing. Make sure to put a parenthesis around everything you are dividing. So 0.0216 times 20.4297 divided by parenthesis 38 times 492.5. Close parenthesis. And the number that my calculator spit out for me was 2.3579 times 10 to the negative 5. And again, like always, last thing we check for is Sig Figs. Whenever you have a problem that's just putting numbers into formulas, all the numbers are measured. So this has 3 Sig Figs. This has 1, 2, 3, 4, 5, 6 Sig Figs. This has 2 Sig Figs. And this has 4 Sig Figs. Of those, the smallest one in this multiplication division problem was 2. So my answer only gets to have 2 Sig Figs, which means that I need to round it. So I'm going to keep the first 2 places. This will round this up to a 4. And this would be the answer that I report for this problem. So for 23, you're going to have a problem that has a different formula, and I give you numbers. You will want to arrange the equation so that you solve for the missing variable, and then plug in the numbers. Just like we've been doing in class, do all the units in the algebra first, and then do the numbers last. That way you aren't constantly writing these numbers over and over and over again. It will get you confused if you do it that way. I know a lot of people like that because they want to just plug in the numbers as soon as they can. Save it for the end. You should savor it. Something like that. I don't know. But doing the algebra first is the preferred way because it is easier to do all the algebra steps while you're thinking about algebra, and then do all the number steps while you're thinking about numbers. 24 is exactly the same as 23. However, there is a trick to it, and I'm going to show you that trick in just a second. So go ahead and finish copying this down. I'm going to get a drink of water. All right, let me set this up for the next problem. Boop, boop. We'll do something very similar to what we just did. So let's suppose that I have these these four variables arranged like this, and I want to solve for D, where A is 11.8, B is 0.272, C is 34.915, and D is what I'm asking you to solve for. The first thing I'm going to show you is the wrong way to do this, because a lot of students do this on accident. So, really important. What we're going to do here is wrong, which is what I'm going to write on the screen. So you see D right here, and you might think, oh, I just got to get D by itself, so I'm going to move C over to the other side by dividing both sides by C so that the C's cancel. And then my result would be AB over C equals D, because D is by itself. But if you look carefully, you'll notice that D is on the bottom of a fraction. What you've actually solved for is this. In fact, there's not just a blank on the top. What's on the top now is, well, what's C divided by C? It's just 1. So if you solve in this way and you leave your variable on the bottom, you get 1 over what you want. And that's not the correct answer. So this is no good. Okay? What you instead need to do is you want to solve for D, but D has to be on the top. Otherwise, you're solving for 1 divided by D, which is known as the inverse. So going back to our problem here, A times B equals C over D. In order to get D on the top, I have to multiply both sides by D instead. So that this D cancels out and is off the bottom, and is now on the top over here. And we get dab, so you can dab or whatever. So now my equation looks like this. I still want to get D by itself, and now that's easy because I just divide by AB so that it goes away on the left, and it remains on the right side. So that now the equation becomes D by itself on the top, which is what we want, here. And you'll notice that this formula is actually what this was upside down. So if you get the inverse, you can actually flip it over to get the correct answer. 1 divided by D, if you take its reciprocal, would be D over 1, or D. Whereas AB over C's reciprocal is just you flip it over and you get C over AB, which is what we have. That's an algebra trick that you can do if you accidentally solve for the inverse. But when you're beginning, it helps to just do all of the algebra. Then we would just take these numbers and we would plug them in down here and we would get an answer. I'm going to leave that for you to do because we just did a problem like that. I trust that you can plug in numbers. No problem, that's what I'm here for. That's 23 and 24. We're going to talk about 25 a little bit tomorrow when we talk about density. But I can do a sample density problem very briefly, just to show you that density is a conversion factor, and you can use that to help you. So I'm going to clear the screen in just a second, so make sure you get anything you need from here. And it's gone. Boop. Yeah, so these problems don't have units written in them. I've just given you numbers. Later on in Chapter 7, we're going to use that PV equals nRT equation, and then there will be units, and we'll show how you deal with those then. They cancel out. There's a special constant that has all the units in it, and you just cancel out the ones that show up. But for these problems, there aren't any units written down because I didn't give them to you. So you can ignore units because there aren't any. All right, I'm going to give you aluminum for this problem. instead of copper. This is the density of aluminum. It is 2.70 grams per cubic centimeter. Remember that any number that is written with a fractional unit like this can also be expressed horizontal or vertically like this. And now what that means is that I can use that as a conversion factor. Because remember that I could just flip this upside down for any conversion, and it still works. It's still valid. So the question that I was asking you in the worksheet was, if this is the mass of my penny, what is its volume? So let's suppose that I have an aluminum can that weighs 39.9 grams. What volume of aluminum is used to make it? So if I had like a lump of aluminum, what volume would I need to be able to make this? And so the way that you do this is just like any other dimensional analysis problem that we've done so far. You would say, okay, I have a mass, and I need to turn it into a volume, and the volume would be in whatever units you want it to be. Do I have a relationship that connects these two? I do, and it's right here. It's the density. So I could say that for aluminum, 2.70 grams of aluminum equals a cubic centimeter of aluminum. Now that I have that relationship figured out, I have my units linked together, I can then go over to the problem, and I can do dimensional analysis. I don't want grams. I'm going to turn it into the linked unit, cubic centimeters. So I'll set up my units like that, so that these cancel. This is a volume. That's what I want for my answer. So now that I've got the units all set up, I will get the unit that I want out. I can do the numbers. My relationship for density was 2.70 grams per cubic centimeter. So I had to put the numbers in the right spot, 2.70 grams per cubic centimeter. And then I'd punch it in the calculator. 39.9 divided by 2.70. And I got 14.778. Which again rounds to 3 Sig Figs because of both of these. And that's the answer I'd report. Yep, 23 and 24 are no units, because I didn't give them to you. 25 does have units. For this problem, I wanted cubic centimeters. For the worksheet, I want you to tell me it in liters, which means that if you got to this point in your problem, you would then have to take your centimeters cubed, and you would have to find a way to get to liters. And I'll give you a hint. You do know that centimeters can be turned into milliliters, because 1 cubic centimeter equals a milliliter. And so you should be able to figure out how to get to here from there. I can't just tell you the answer. All right, that's 25. The rest of the problems, I believe, are just things that we did in class yesterday. With the exception of maybe 16, which is just, here's a velocity, turn it into another velocity. But we did that example in 22. All right. I'm going to take a 10-minute break. And then what will happen at the end of the 10-minute break is if there are any questions in the chat, we'll go through them. If nobody has any questions, you can just take off. If you're finished with what you wanted, you're free to take off. I'm going to put this on the board. That's not the title card because I moved the title card. I don't have my timer. Hold on. Live split. All right, timer should appear now. Nope, that is a new updates are available. That doesn't help me. There we go. All right, so I'll give you 10 minutes. I'll start the timer. I'll put the music on. Go ahead and take a break. Make sure to type in any questions that you want. If there's absolutely nothing in the chat, then I will just say, okay, the stream will end now. And we'll see you on Thursday. So there we go. See you in a bit. Looks like I answered everything in the chat here. Any last questions? Get them in real quick. Oops, I cleared the announcements for some reason. There we go. That's what I meant to do. It doesn't look like there's any questions. So I'm going to shut down the stream in just a minute. Thanks for showing up if you are still there. If you have any questions about the lab assignment, feel free to ask them next Wednesday as well. You can also ask me during the week via email or on the discussion board, anything that you want. Again, I can't tell you the answers, but I can give you similar problems and work through those so that you can use that knowledge to apply to the correct problems that you'll be doing. Have a good night. Thanks for watching, and I will see you tomorrow for the rest of Chapter 2's lectures.